So now we'll round out the data gaps and uncertainties part of the ecological risk. And my standard thought is if you don't like uncertainty, don't do risk assessment. And that's certainly the case we have with PFAS right now. It's not necessarily going to paralyze us and keep it from making decisions at sites, but it's definitely very challenging. In regards to our exposure modeling work that we put together in the guidance and the way it's handled in the ecological risk assessment, I've listed a few of the, more significant uncertainties you should probably be aware of. One of the things the model does with fish, for example, it focuses on predicting concentrations of PFAS in the muscle or carcass tissues. And that's basically a result of the model parameters that we needed for BCFs and BMFs. All were coming from mechanistic studies we selected with high uncertainty. The issue was they were focused on carcass measurements. We're basically taking that fish, analyzing the organs by itself, and then analyzing the rest of the fish, the carcass. We focused on that as a semi-reasonable approach to get at the whole body concentration, or even the fillet concentration if you're doing exploring human health risk assessment, for example. The potential issue here, the detail to be aware of, is concentrations in liver and kidney in fish are often higher than what's in the muscle. And that's, again, makes sense because the liver and the kidneys, some of those organs are protein-rich tissues. These stable alkyl acids like proteins, they're proteinophilic, so they'll preferentially accumulate to higher levels in the liver and kidney. So that's something to be aware of. There is some, information out there when they've done carcass or fillet versus whole body. The whole body might be higher. I think we need to do some more research into that, evaluate that a little bit further. In the studies that we've looked at, where we've had sediment, water, and measured fish tissue concentrations, but we've just taken the sediment and water and plugged it into the model actually does pretty well at predicting what's in a whole body fish concentration. Not too bad. We've looked at a couple in the Larson paper, a few other case studies we've looked at from other data sets. Again, that needs to be validated. We're hoping to get more information and keep refining the model and evaluating that. And we're on the lookout for other model parameters where we can adapt to whole body when that research becomes available. The other issue is precursors. I think someone brought that up earlier. Precursors are the 800-pound gorilla at some of these sites. How do we evaluate what's going on with precursors? Our models tend to stop basically at those stable acids. We have 3 PFAS precursors involved. Again, a major point of uncertainty right now in dealing with those precursors. I think that's really an active area of research to evaluate data gaps. Right now, though, people need decisions made, and basing them on the stable alkyl acids is really our only choice right now. There's not a great way to take that precursor data and make something of it or analyze all the precursors that are available. We mentioned the top assay earlier. That's not a perfect tool. It may overestimate risk. It may not capture some of the compounds that may be transformed to some stable acids. But really getting at that is really a key data gap. One of the other things we looked at, uptake in aquatic plants. We're assuming that it occurs via the water only. That may not apply to some aquatic plants that are rooted in sediment that may have PFAS present. If there's uptake from the roots, that's a potential data gap. Also, our terrestrial model for plants right now looks at uptake into the above ground portions like the leaves and the fruits. It doesn't necessarily target the roots. So if you have an animal at your site that preferentially eats roots, you may need to come up with different uptake factors for roots. There are some out there. They tend to be lower for most PFASs because those leaves accumulate quite a bit, especially the shorter chain compounds. Surrogate values, again, I can't stress enough, that's probably a very useful tool right now for uncertainty analysis and tinkering around. Basing major decisions on those surrogate values is probably not recommended at your site unless you're extremely desperate. It's better than not having a number to put in, but again, take it with a gigantic grain of salt when you're using those unverified approaches. Again, we put it out there as an example. There may be other good ways of doing that or other research that's generating data really week by week coming out. There may be values to put in and fill those holes very soon. So be aware of that. As far as the effects, most of this information, again, was brought up earlier, is based on rodents, mammals like the mice and the rats that are common test organisms for these tox experiments. What do we do with real effects on wildlife species? We need more data out there, again, looking at actual site exposures and effects in the field. That research is slowly coming together. It's going to take a lot of time. Are we going to have it on every PFAS out there? Probably not. But we know at least a little bit from the stable alkyl acids. So there's not a lot of data on avian toxicity, as I mentioned earlier. That's a big data gap we've highlighted. Mixture toxicity is a huge issue as well. You'll notice in the worksheets we've generated hazard quotients. We don't necessarily have a cell that sums those into a hazard index. There's no basis to assume yet that we should be summing PFAS exposures and treating them as additive. Or are they synergistic? Are they antagonistic? Work needs to be done there. And even then, can we do these across multiple classes of PFAS compounds, or are we going to be restricted to summing carboxylates or summing sulfonates, for example? Really, the jury's out on that. More research really needs to be done. Again, surrogate TRV values, as with the bioaccumulation values, there's a lot of uncertainty. Again, useful for probably a sensitivity exercise in your risk assessment. Do your conclusions change if you assume that everything is as toxic to birds as PFOS is? Does that conclusion change your overall risk assessment or not? Useful to play around with, potentially making major site-altering management decisions on it. Maybe not. It's difficult and careful process to wade through there. Other PFAS, that are currently measurable, not measurable. Pardon, let me back up. What do we do about other PFAS that are not currently measurable using the typical analytical methods that are available to us from our commercial labs? Again, a huge black box. It's the dark matter of PFAS at sites. Precursor compounds, other stable compounds that may be present that aren't quantifiable. What do we do about that in terms of managing risk at sites? Is the hypothesis that PFOS will drive risk-based decision-making at most of these sites valid? I think it needs to be tested. Can we make management decisions on the basis of one or two compounds to protect the ecosystem or the site resources from the variety of compounds that may be present or there that we may not know about? That's a big uncertainty. We face that issue when we're dealing with petroleum hydrocarbons, some of the pesticides and other compounds that we deal with, that we may have a few indicator compounds to measure, but there may be other things that are present that we don't know about. That's, again, a fact of eco-risk or human health risk assessment is dealing with that uncertainty and communicating it effectively. Other data gaps. In the process of going through the literature, looking at the evaluation of different data sets, we said, key issue that we can put forward to help DoD and the research community is, what are the values that we're missing? So we looked at really the availability of the bioaccumulation and toxicity parameters we collected. We looked at really the types of PFAS that are found and where you find them at AFFF sites. And we got that mainly from looking at the Anderson et al. 2016 review of the Air Force sites, where a variety of compounds were measured in soil, groundwater, surface water, sediment, things like that. Really looked at how frequently those compounds were detected, the magnitude of those detections. And then we kind of did a cross-matrix reference of the two, thinking about relative bioaccumulation patterns, exposure potential, toxicity, and you aren't able to see this from the back row for sure, but we put together a big matrix to say, of the compounds, the various exposure pathways we're thinking about, how often you're finding these compounds, what's really sticking out in terms of which compounds are really going to be driving the bus in terms of risk, and do we have the information right now to put together an eco-risk model? And considering that, PFOS was really a high priority chemical, but we have a lot of information about PFOS. So beyond that, what other compounds do we know little about that could represent potentially important exposures? So we use that to kind of do some prioritization of which compounds needed to be evaluated further, and specifically which endpoints. Do we need more bird toxicity information? Do we need earthworm uptake data, for example? And so we put together a list of really concrete things for researchers to chase after in the next few years, and hopefully for DoD and other funding agencies to consider prioritizing when they're releasing requests for proposals. We should be targeting really getting more information on the birds, for example, actually doing some ecological measurements and field work at some of these AFFF sites where we're hypothesizing effects. We actually need to be doing some of this work. Looking at other things like toxicity to some of the plants, for example, beyond just PFOA and PFOS, doing some more modeling considerations and building some more information for terrestrial systems, for example. Working towards mechanistic models of toxicity. EPA's doing some work on that now. And then developing some additional uptake factors to flesh out our bioaccumulation models, especially looking at some of those higher trophic level transfers, like going from rodents to predators, for example, and other upper level trophic transfers might be important. So, conclusions. Kind of reiterating some of the main points from today. AFFF sites, when we think about these sites, when we start building our conceptual site models, we're often thinking beyond the airport, beyond the military base, down gradient, where water is carrying these compounds into habitats, especially wetlands and aquatic systems that receive runoff from these sites. Usually there's not a lot of habitat at the airport itself or the training area. It's usually paved areas we showed earlier, gravel impacted, it's a managed system. But what's going on down gradient as these compounds are carried in the aquatic systems? Looking and thinking about really what animals and resources are critical to protect. I think our modeling work and our review has really shown small birds and mammals to be particularly sensitive and probably going to be driving a lot of the risk concerns at sites because they maintain a high site fidelity to a lot of these areas. They eat a lot of food for their body weight per day. They're highly exposed. They interact with sediment, water, soil in very intimate fashion, so they get a lot of exposure. So really start focusing on those small animals. And it's not really any big surprise to most ecological risk assessors in the room. The shrew often drives concerns at sites because it's small. It remains in a small area. Those small birds, the little, invertebrate eating birds that maintain a small home range tend to drive concerns at a lot of sites. I've talked a lot about uncertainty today. We've talked a lot about missing values. It shouldn't necessarily paralyze us from decision making. We can come up with some decision making approaches for sites now using the best available information, and that's really what we're trying to put forward with this guidance. Really, we can put together some models that may not address every single pathway and every single chemical, but it gets us a lot of the way there and can allow us to start designing some investigations and maybe even some decision making and management at some of these sites. Looking beyond the information for effects, there's some good TRV coverage for mammals. We need some more data on birds. Birds are going to be a key factor for some of these sites. And, we need a lot of good other effect information out there. So that's really a key thing for researchers to follow up on, is trying to get a handle on effect information and toxicity data. Thinking beyond, what to do about key uncertainties and data gaps. Number one and number two is, what do we do about mixtures? What do we do about those PFASs that we can't measure or may be measuring that may be PFAS precursors and transforming to those stable acids, for example? What do we do about that information? How do we come up with a good risk management approach for those? That's going to be a key challenge. So PFAS ecological risk assessment, it's not perfect yet, a lot to learn, a lot to develop. but we can start to make some technically defensible decisions. And in a lot of cases, we don't have the opportunity to wait for a perfect data set or set of parameters. Some of the information, some of the sites that are out there need decisions now and can't be delayed. There's a lot of the good tools, guidance information we've put together are available at our CERTIP webpage. We hope to continually update that over the next few months as we get additional information and feedback on the model, for example. We'd love to hear about suggestions or other criticisms. Please email us, let us know, and then we're also going to post this YouTube video as well on the website, and also upload the terrestrial model when it becomes available too. Some thank yous in the last few minutes we have here. Special thanks to CERTIP for funding us, and Emily Larson, a key earlier member in the team putting all this together. So thank you to her. Again, I'll remind everyone today, the slides are going to be available in PDF. Just email us for a copy. Happy to send one via email. The workshop should be available recording in YouTube probably in about a month or so. And then, if you have any questions about any of the information today, feel free to reach out. Our emails are there. And thanks again for coming today, and appreciate your time. Thanks a lot.